Greetings. Joseph Kursky here with you. I was recently asked by a secondary school to give a presentation for a capstone course for seniors focused on what research is, why research matters, and how students can embrace it. To support this presentation, I created a story map that you see here that you're welcome to use wholly or in part for your own secondary or university courses and students. As I often do, I presented this content as a story map. Story maps from Esri, ArcGIS story maps, offer several advantages. The ability to easily embed maps and other multimedia, the ability to share, and the ability for me or you to go wherever I am presenting or you are presenting and pull the story map up on any device. The students could also do so on their own devices and follow along as I presented. My primary goals of the presentation were not to provide an all-encompassing definition of research, but rather in a short, compelling way to do the following things that I hope to share with you right now. Thanks for being with me. Why research matters and how you can embrace it wisely. What is research? Take a look at this door, the data door. I found this at a university that I visited as part of my work, and I thought, gosh, what's behind that door? The data door. It's intriguing, and so it's providing I hope, a useful introductory thing to think about. What's behind the research that you will uncover? And data is also fundamental to research, as we'll talk about. What is research? It is a systematic investigation into and study of materials and sources in order to establish facts and reach new conclusions. Systematic. It's not a haphazard, random, casual sort of activity. Although, when you look at some of the key research and breakthroughs that have occurred in the past, serendipity, happenstance, random chance oftentimes leads to breakthroughs. So don't exclude those things, but it's in essence a systematic investigation. It is something that you take seriously and something that is purposeful and has a goal and a set of objectives. And to reach new conclusions, to advance knowledge, as we'll talk about. It's also, you can think about it as a systematic inquiry, asking questions and investigation that entails collection of data, as we just talked about data briefly, documentation of critical information, so you're documenting as you go, keeping a record so others can follow what you're doing and build on what you're doing, and analysis and interpretation of that data and information in accordance with suitable methodologies. So you're doing your background research, you're finding out what have other people done in this area that I'm interested in and how can I build on what they've done. So you're not in a box isolated. You're tapping into and you're looking at, you're being aware of other research in the area that you're interested in. So suitable methodologies set by specific professional fields and academic disciplines. And those disciplines are wide-ranging, as we'll talk about, ranging literally from agriculture or archaeology or anthropology to zoology and everything in between. Research is conducted to do several things. Evaluate the validity of a hypothesis or an interpretive framework. What's your question about how these two variables interact or how the world works in a certain specific part of the world or a certain specific set of variables in that world? Or in your community, or any scale in between. Community, neighborhood, city, urban area, region, country, international, global. Also to assemble a body of substantive knowledge and findings for sharing them in appropriate manners. And also to help generate questions for further research, for further inquiries. Let's first talk about, before we go further, what is research not? I want to dispel any sort of preconceived notions you might have about research. Research is not some boring old thing that only ancient scientists did. Some of those things actually I find quite fascinating, but it's not that. It's not only that. Sure, ancient scientists have done research. Modern scientists, you are doing research, and it's everything in between. But it's not just something that was in the past and is done. We're done with that now. We've arrived at our modern era and we don't need research anymore. No, that's not it. It's also not spending years in a dusty lab poring over specimens, fungi, microorganisms, maps, my own field, whatever. Although some of those things are actually fascinating to me. But it's not just locking yourself into a lab for years. It's also not just some tedious thing that your teacher or professor assigns you to kill time. Rodin's The Thinker. I love that. We want to think thoughtfully about this.
So, no, it's not any of those things, or exclusively those things.
What is research then, and why does it matter? We've talked a little bit about what it is, but now let's talk about why does research matter. Here is a graphic that I hope illustrates my points in the next few moments, and that is as follows. These are actual photographs and maps that I've taken. Research is modern. It's field-based. You could be studying rivers, ice, glaciers, soil, other planets. In other words, a lot of this work can take place in the field. It's also lab-based. You can be in a lab, and the lab can be wide-ranging. Don't think of it as just test tubes and Bunsen burners. Okay, lots of different kinds of labs. It could be a soils lab. It could be a lab, a medical lab. It could be a lab where you're getting input from about people's attitudes in a field survey, etc. So lab-based. Labs can be far-ranging in scope, size, location. It's also high-tech. We're using modern, high-tech methods. It's also exciting when you think about, hey, you're expanding the frontiers of knowledge.
The frontiers of knowledge.
You have a high calling with your research. You may think that you're just looking at this little piece, but gradually we're building a wider knowledge base so that we can make people's lives better, which is the ultimate goal, as we'll talk about later on. It's also, to that point, needed. Research is needed to advance knowledge so that we can build a more sustainable, equitable, more resilient world. That is the purpose of research, to make people's lives better. Progress is made through discoveries, and those discoveries are usually made through a systematic research study. Examples: penicillin, transplants, and other medical breakthroughs. Those have all been, we're standing on the shoulders of giants, folks. Those advances were as a result of research. The World Wide Web, you're looking at this over the web right now. This is a story map that I've created. The web was created through a series of years, decades really, of advancing communications, telecommunications, computing science, etc. That we've got this web available at our fingertips. Wow. Airplanes. How many of you have flown in an airplane? That's a result of decades of research. And spacecraft too, for that matter. Rockets, the International Space Station, probes for the moons of the solar system and other planets. Spacecraft. Electricity was the result of lots of decades of tinkering and experimenting and research. Cell phones. Do you have a cell phone? That's a result of a lot of research that has gone into how do we get the minerals and the materials for that phone? How do we get the communications network set up so that we can actually communicate with each other? And what about the apps? All of those were developed as a result of research. Recorded music. Hey, do you like your tunes? Recorded music, that's a breakthrough, right? For millennia, people had music that was local. It was shared with a group of friends or family. There was no recorded music until the late 19th century, early 20th century. So having that available, wow, what a breakthrough. The food you ate today, agriculture, supply chain management, that was all a result of research. How did it get grown? How was it packaged, distributed, delivered, and so you can consume it? The water you drank today, that it was safe and clean. Now, I realize that's a sustainable development goal of the UN. We haven't solved that for the whole world yet, but we're working on it. But the water that you drank today, water treatment and looking at microbes in water and how do we clean it, that was as a result of research. So be thankful that there's research for the things that you enjoy, but also the things that keep you alive today. What does research accomplish? It can help us understand 21st century issues and solve them. Health issues, not just COVID, but other health issues, preponderance for certain diseases or infections, lifestyles, exercise, etc., the food that you eat, and how does it get converted into energy and health. Energy in our world, lots of different forms of energy. How do we power our modern economies? Climate and weather. sustainable fisheries, habitat, not just for humans, but for other plants and animals. Water quality and quantity, we touched on that a bit earlier. Transportation, how do we move goods, people, services around? Supply chain management, and many more. It helps us understand, grapple with, and solve these 21st century issues that are complex in nature and increasingly affect our everyday lives. Research builds knowledge and learning, as I touched on earlier. It builds those things so that we can advance in our understanding, in our knowledge, and our ability to move forward. It can increase public awareness of an issue that perhaps you care about. You want other people to care about it too. It can help do that. Research helps build a vibrant economy where we can thrive, feed our families, and so on. Research helps us build a more sustainable, equitable, resilient future. Research promotes a love of and confidence in reading, writing, analyzing, and sharing valuable information. So it connects with the other things that you're actually doing in school or at university. Research provides nourishment and exercise for the mind. You are a researcher. I want to give you confidence that you can move forward in this. You were a scientist at the beginning when you were a little kid, right? You would look at a little roly-poly bug and wonder, why does it curl up when I touch it? Or look at a little blade of grass with your pudgy little finger, right? You were a scientist from toddler onward, really from infancy onward. You were always investigating your own little crib, and then your room, and then your neighborhood, and so on, right? You were a little scientist. Don't squelch that inner scientist that we all have. Research enables you to pursue your curiosities about the world. And in tandem with that, I also encourage you to ask questions, even as a young person, as an adult. Don't lose that. Keep asking questions. More about that in a bit. Actual researchers I worked with at a university. We're talking about Belize here. We're looking at coastal erosion. We're looking at coastal aquatic life, how to protect it, how to maintain sustainable tourism, how to work with local people for sustainable agriculture and livelihoods. Now, this is a graphic, as you see here, on the geographic inquiry process, but I want you to also think about the scientific inquiry process, which is very similar. You're asking a question, or a set of questions, about phenomenon, issues, events, themes, variables. You're acquiring resources to help you answer those questions. Those resources could be data, it could be tools, it could be knowledge. You're exploring that data in various ways, through statistics, through mapping, through lots of other techniques, data analysis. You're analyzing it, you're exploring it and analyzing it. You're coming up with conclusions about what you've learned, and then you're inspiring people to act on it. Maybe you yourself would act on that geographic knowledge. What are you going to do? What are other people going to do with the newfound knowledge that you're sharing with people? And then you're asking new questions as a result of that. So the cycle continues. It's not just I'm asking questions, I'm researching, and then I'm done with that. No, you keep asking questions about those things. I encourage you, while you're doing your research, you're not going to be able to answer all the questions that you're asking. Keep a digital or a paper tablet with questions that you're uncovering as you go. You might be able to uncover those and grapple with those questions. Fascinating. But keep a running list of those questions. That will help you, as many researchers have discovered in the past. Is research hard? I often get this question from students. Well, sure it's hard. Learning is hard. Investigating is hard. It's not easy. But most anything that is long-term endeavor is hard, it's challenging, it's difficult. Consider these examples. Being a parent is hard. Being a student is hard. Learning a language, a musical instrument, running a 5K race in under X minutes, whatever your goal is. How to weave, how to paint, how to sculpt, how to do any sort of craft. That's hard. Loving someone, that's hard. That's challenging. Research is hard, but it's worth doing. It's worth doing, and I encourage you to do so. I think another thing that is actually oftentimes not asked is, how much research do you need to do? I think it's important when you're doing your research to put a boundary on it, because it's sort of like helium in a hot air balloon. it keeps expanding no matter, to the extent of the fabric on the balloon. So in this case, your research could encompass every single moment of your existence. And you don't want that. You want to be able to do other things as well, and you've got other tasks and jobs that you need to do day to day. So set boundaries. How much research do you need to do? It depends on your task, your research task, and your job or jobs. How much is enough? Having a set of goals and objectives. You're not going to be able to uncover all the stones that you're turning over. Okay, you're not going to be able to fully investigate all those research questions, stones that you're uncovering. But you'll be able to do some. You'll be able to answer some of those questions. Allow a block of time. Say, okay, Friday, last day of this month at 5 p.m., that's going to be the end of my, at least initial phase of my research. And I'm going to put boundaries around it. And whatever I have done then, I'm going to write up, summarize, and share with others. But that said, allow some time for discovery. Remember I was talking about earlier about people finding things because they were involved in an experiment. I mean, penicillin is a great example. Hey, this got dumped into this moldy, I think, piece of bread is what it was. And as that mold grew, that actually has properties that I might be able to use to help people with infections. So it was sort of a random bread falling into this dish. You can do more investigation on that story. But there's things that just happen as a result of research oftentimes. So allow some time for investigating some thread. Don't have it completely locked down in terms of these are the questions. Allow some time for discovery and investigating some other pursuits and questions. Recognize your own bias and worldview. There's oftentimes this attitude and this mantra that research is completely objective and dispassionate. You are completely dispassionate and disconnected from your subject. Well, you have a worldview, the way you were brought up, your background, your family's background, etc., the way where you grew up, etc. Okay, your experiences in life. That's actually a good thing. I think that's to be celebrated. You can contribute in a way that no other person on earth can. You have a unique set of attitudes, backgrounds, etc. But recognize that, you are, because of your background, you're asking questions selectively. You're not experienced with this whole other way of looking at the world, for example, that maybe someone else is. So just recognize that you have a bias, a set of biases, and worldview. Again, that's a strength, but also recognize that you're not completely objective in your research. Don't get stuck in the weeds also. Keep the end goal in mind. Don't get too sidetracked by bunny trails, for example. And this is a set of colleagues and I right before a workshop that we were doing some research in. So collaboration with others is oftentimes necessary. Now, I want to share with you a little bit of my own research background because I want you to get the idea that I'm not telling you to do anything that I'm not doing myself, okay? These are life lessons that I've learned in my own research over the years, over the decades, and I'm hoping it's helpful. In my own case, my pathway is actually involving 4 different sectors of society. Nonprofit organizations, so for example, I was president of the National Council for Geographic Education. I've worked in federal agencies, science and mapping agencies, NOAA, Census Bureau, U.S. Geological Survey. I'm in private industry now, working as education manager for ESRI, Environmental Systems Research Institute, a private company involved in geotechnologies, more about that in a minute. And I'm also involved in academia, so I teach. I love teaching. I love inspiring people to achieve their goals in geographic information science, geography, and other sciences. So I teach in various places, University of Minnesota, University of Denver, St. Galeska University, so I'm involved with tribal colleges as well. So that's my own background in nonprofit, government, academia, and private industry. And as a young person, I wanted to be a geographer right from the get-go. And that might be your experience too. You wanted to be a chemist. You wanted to be a social worker. You want to be in business. You want to be in engineering. You want to be in data science, whatever. And you had that goal from the time that you were a young person. Others of you are still trying to figure out what pathway should I pursue. Either one of those are okay. You don't have to be from age 5 onward. I want to be in health sciences. No, that's okay if you're just figuring it out. I've got a lot of students in my University of Denver course, for example, year to year that are mid-career and they're still, okay, I want to change. That's okay too. As a young person, in my case, I would take pictures of the built infrastructure, so cities, towns, and also the natural environment. I get a certain angle in a building or on a cliff or on a slope in a mountainside or something like that. And I would take that certain angle in that certain time of day. So I was always very keen on getting outside. I loved technology, and I also loved maps. So as a young person, I would make maps of made-up places like you see here. This map is based on reality. It's my imaginary place, though, that's basically a city on a bay with an estuary, 2 rivers running into that bay. I've got freeways, I've got railroad yards, I've got parks, airports, Air Force bases, piers, neighborhoods of various kinds, trails, all running through my city. And I've got lots of these on big poster board, and I actually hand-colored these all with colored pencil, crayons, etc. My current research, again, I'm sharing this with you so that you can say, hey, Joseph is a researcher also, and he's encouraging me in my own research path. My current research is on geographic information science, very much related to what I was interested in as a kid. So for example, here, this GIS for science, let's pop that out in a separate tab. Geographic information sciences is grounded in many sciences. It's sort of a bridging science that bridges, you can see here, species analysis, coastal erosion and landforms, energy, oceans, artificial intelligence, space exploration, the mapping the human brain, all sorts of things that are involved with this geographic information science. So GIS, Geographic Information Science, is a science in itself, but it's also a bridging sort of a discipline that bridges many other sciences in the whys of where, the whys of where. Why are things located where they are, and what can we do to make a better world? My own specific research is on teaching and learning with geotechnologies. So for example, here's one of the recent articles when we talk about, hey, where do you publish the results of your research? How do you share your research? This is one way, through an article, a peer-reviewed article. So this one, as you can see, is all about teaching and learning with geographic information systems and geography using field tools and spatial thinking. So this was an article I wrote for the Geography Teacher Journal, and here is my article right here that you can take a look at. The other related aspect of my research is the implications of using data to make maps. How to find data, how do I know if it's any good, and societal issues like copyright, ethics, location privacy, charging versus not charging for data, the open data movement, and so on. So my colleague and I maintain a blog called the Spatial Reserves Data Blog. It came out of a book that she and I wrote on this topic, and the point is that we want to keep the conversation going. So one of the things in there is really focused on location privacy. For example, how many of your phone apps are sharing your location right now? When should you share your map data, your fitness app, etc.? And who should you share it with? And does it matter? So thinking about location data. Also related to that, I'm very keen on helping people to be critical of data. Don't just accept it because it's on the web, or don't just accept it because it's a research study. Really investigate the methods that they use, the framework, the variables, the workflow. Be critical of all data, especially and perhaps most importantly, maps and spatial data, because they have this air of authenticity. Maps kind of look authoritative. Because for decades, for centuries really, the only people that could make maps were authoritative science agencies. It never meant that those maps were perfect, but those maps were from science and data organizations, mapping organizations. Nowadays, anybody, including you and I, can make maps. So you see all kinds of maps that are of dubious or quality or just plain wrong. Argentina, oops. On this particular newscast, it's up in Colombia. That's not Argentina. Argentina is further south. So errors on maps. Sometimes maps look okay. They have an intriguing theme, passport ownership by per capita by state. But look at the legend here. It makes absolutely no sense. Less than 20%. Look at this, more than 30%. Should that be white or should that be this teal color? I don't understand that legend at all. The Internet of Things is increasingly feeding our mapped data and our everyday decisions about whether to wear a coat outside at the bus stop, etc. But sometimes those feeds are wrong. I know it gets hot in Texas, for example. This is really hot, really wet. Look at the precipitation rate, really humid off the scale, and really windy. So it's the only thing that's normal on this particular Internet of Things feed is the pressure. So for a year, this was online and it was in error. So if you were making an interpolated surface out of the weather data for Texas or the USA or North America, you'd have a big spike at Cleburne, Texas, which is clearly an error. So be critical of even the Internet of Things. It's wonderful that we have these data sets at our fingertips. Wildfire perimeters, stream gauges, earthquake epicenters, traffic, weather, but they can be in error. Imagery must also be viewed critically. It could be intentionally offset or selectively offset. Look at this Google map over in China. The image is, look at the bridge in the image, but then look at the bridge in the vector data, the transportation. It's offset by 1,800-ish feet or 557 meters. Neither one of them are actually spatially correct. They're both offset for various reasons. So be critical of even imagery. Also, data could be intentionally faked, as I wrote about recently with this notorious example right here. Data could be intentionally faked. Not often, but it can happen because more and more people have access to these tools. Okay, so be critical of that. We have tools, for example, my organization, Esri, makes a 3D scene viewer where you can model buildings, mountains, valleys, etc. And you can also create weather on it. So, for example, I've created a snowfall and a snow cover of our headquarters building in Redlands, one of our headquarters buildings in Redlands, California. It snows up in those far hills in there in the distance, but it never snows down low like this. This is like 34 degrees latitude and in a hot environment. Okay, it's near the coast also. It never snows like that down in the valley there. So this is not possible, but you can simulate it in these tools. Take a look at this scene viewer. For example, we've got the 3D scene viewer. That's one of our tools inside ArcGIS Online. And you can, with amazing clarity, drape building facades, imagery over a landscape. Remember, though, this is just a image. It's not reality. It's a simulated view of reality. Maps are imperfect representations of our real world, okay? The real world is complex. We are representing it with maps and spatial information. They're imperfect representations of reality. For example, we've got this oblate spheroid. It's rounder, it's wider around the equator than it is around the poles. So we've got map projection and other distortions. Maps are very useful representations of reality, but they are representations nonetheless. That's part of my research. Also, key information might be left out of the metadata or the data associated with maps and geographic information. And sometimes that information can only be resolved by talking to the data creator with an old-fashioned phone call or an email, as was the case when I was revising my Lyme disease map of Rhode Island. It looked like the incidences of Lyme disease were going down. It wasn't really the case, though, because the state agency had less funding in the data decade that I was revising. So the data looked like we were going down, the rates were going down, but it really was because of the lack of funding. And they weren't reporting as many diseases, cases, as in the previous decade. So again, investigating the source is so critical when you're doing research. Now that brings me to my top 10 important skills to cultivate as a researcher. My recommendation to you all. Is this the only set of skills? No, and it may be not your top 10. We can have a debate and discussion. I welcome your comments about this. But this is, based on my experience, the most important skills. Again, debatable list to be sure, but the most important one, I think, I hinted at this earlier, ask questions. Be curious. Curiosity leads to you asking questions. It also leads to you being tenacious about the tools that you're going to use, the skills that you're going to develop, etc. What skills do I need to develop to be able to answer this question? What data do I need? So be curious. It includes learning and using a variety of methods, tools, and approaches. So ask questions. That is going to be valuable to you your whole life long, not just in school or university. Ask questions that I encourage you to ask questions that your instructor is not even asking you. And when you get into the workplace, ask questions that your supervisor, your boss is not even asking you. Those are the kinds of employees that are really valuable to an organization. Ask questions. Number 2, use well-rounded sources. Do I allow my students to use Wikipedia or Wikimedia for some of the sources? Sure. Crowdsourced libraries are valuable in their own way, but not exclusively. Use journals, books, articles from a wide variety of authors and fields. So here's an example of a reference list from one of my own articles. You can see here I've got this report from a association as one of my references. I've got an article in the Annals that I actually co-wrote, so it's okay to cite yourself as you go forward in your career. You're going to have more things to cite, including your own. Here's an article in a newsletter, so it's just really a post in a newsletter. That's another source that I've got here. Here's a chapter that my colleague Esty Garrity and I wrote for the J Reading Journal. Here is a chapter in a book from Goodchild and Longley. Here is an article in a journal. Here is another article in a journal. Here is an article in a trade magazine. So I've got a wide variety of sources. This is just a little sample of the sources that I've got with a certain article. So use well-rounded sources from a variety of different authors and fields, okay? Third, understand how to use data. Now, I hinted at this earlier. How do you use data? In my own area of work, it's understanding how to use geographic information systems. So, for example, if I've got this litter data and I want to symbolize it in a different way, okay, I'm going to say, oh, okay, these are the sample points where I collected the litter data. And now I want to, let's say, add a field and I want to look at aluminum, okay? So aluminum, and it's going to say, okay, here are the places where aluminum is most prevalent. Let's pop that out in a separate tab, shall we? Just so we have more real estate so you'll be able to see a little bit better what I'm doing. So, okay, once again, I've got some litter points in downtown San Diego that were collected out in the field, and I'm going to go ahead and say properties, styles, and this is using a geographic information system, and I'm going to map aluminum, and I'm going to add that, and now it's going to say, okay, here are the places, here in this place, you've got over 11 pieces of aluminum that were found. Total litter was 31 and over 11 for aluminum alone, okay? And same with these others. You've got different amounts of aluminum cans, probably, that were picked up. Now let's go ahead and add some other fields: glass, paper, plastic, and maybe other kinds of litter. Okay, I'm going to add all those, and now I'm going to get what you see here, a predominance map, where I've got different predominant types of litter mapped, and also the strength of predominance. But you know what? It's hard for me to see those tiny points. So what if I bumped up the size, right? What if I bumped up the size to something larger? Okay, that's a bit large. Let's bump that down a little bit. Okay, so now I'm going to say done, and now I've got, okay, I've got the glass is the biggest problem at this intersection. Aluminum is the biggest problem over here. Paper is the biggest problem up in the Northwest, etc. But now let's go ahead and do this. What if we went to charts and size, and I'm going to say, ooh, now I've got a pie chart for each one of those litter points. Now I can see here that over on this side, I've got aluminum is the biggest problem over by this stadium. Maybe a lot of cans dropped right there. Okay, well, what about this? What if I went to charts and size, went to style options now, and in my style options, I don't want a pie, but I actually want a donut. So I've got a donut shape here. Maybe it's a way for me to understand a little bit better. Now I can kind of see maybe a bit more clearly that, yeah, we've got that aluminum problem over here, but here we've got this glass problem in the north part of my study area in this downtown, in this metropolitan area. The point is, with a few clicks, I'm starting to dig into my data. I'm asking questions, and now I'm asking, what can we do about this litter problem, right? Remember the whole idea of encouraging people to take action on the problem that you're addressing. So I've asked a question about what is the problem with litter in the downtown of this particular metro area. I'm going to map it. I'm going to use some tools. I'm going to investigate, explore, analyze, come up with a solution now. Is it recycle bins? Is it public awareness campaign? What is it? And as I go, I'm asking additional questions. What didn't I collect here? And what if I widened the study area over to the north or to the west or to the east? What would I see across this light rail track? What would I see over by the convention center, etc.? So I'm asking additional questions. And what about other communities? And what have they done to address the litter problem? So that is an example of what I'm talking about here with how to use data. In my case, mapping tools are very important to my work. And I would contend that's actually important to many people's work. The whys of where is very important. Understand how to think critically, number 4. So looking at wildfires and population, I'm thinking about where are vulnerable communities to wildfires? Where's the population versus where these wildfires, in this case, this map shows wildfires over the last 150 years in Southern California. So that's a data set with a lot of information in it. And I'm going to look at two different variables and thinking critically about those two variables and how they interact. Again, why does this matter? What's where, why is it there, and why should we care? What's where, why is it there, and why should we care? Why should we care about populations being in close proximity to wildfires? Well, because people's lives and property are at stake here. Fifth, understand how to think holistically. Here's my photograph of some wind turbines and wheat and weather happening on the Great Plains. I think it's important for you researchers out there to specialize. Soils, climate, population, business applications, supply chain. But don't lose the sight of that our world needs holistic thinkers. The lithosphere is connected to the hydrosphere, is connected to the atmosphere, is connected to the biosphere, is connected to the anthroposphere, the human sphere, the hydrosphere, etc. They're all connected, and we alter variables in one or two of the spheres, we're going to affect variables in other spheres. So it's important to think holistically. That's the kind of thinkers that we need to solve our world's complex problems that increasingly affect our everyday lives. Sixth, know how to communicate a wide variety of information to a wide variety of audiences. So thinking about your objectives in your research, who are you going to communicate that to? Who cares about the research that you're doing? Who do you want to care about the research that you're doing? So, for example, I gave a couple of TED Talks. Some of you have seen TED videos, very compelling videos from a wide variety of people all over the world. I gave 2 TED Talks on the whys of where. Different audience for me because it was a wide swath of the general public. So I had to think about what are my goals? I can't use a lot of jargon. I'm going to have people from, social work to doctors to ranchers to teachers, all kinds of people interested in this topic. So the TED Talk was a good stretch for me. What's a stretch for you? What's an audience that you haven't reached yet? Read. All of the major researchers of the past and present are avid, voracious readers. I would encourage you to read a wide variety of types, genres, and authors. I'm not just talking about research articles here, folks. Read novels, read blogs, watch videos, read, okay? The point is, that will inform your research. It also helps you think about problems. It helps you think about how people have viewed the world from their different backgrounds. Remember, we talked about worldviews. It helps you get in touch with a variety of people. So expands your base, okay, and your inquiry. Also, it's a good conversation starter at gatherings. So if you don't want to talk about yourself and you don't want to just ask questions about, how's the weather, where you lived, etc. Hey, a good thing, I often use this. What are you reading right now? And what's the most interesting thing that you've read this year? And then you have a conversation about books and articles and so on. So I would encourage you to read. There's lots of ways that you can read. It's not just printed paper books, although I do like those. But nowadays you've got, through your public library, for example, you've got Hoopla and Access 360 and other tools where you can actually get audiobooks right on your phone or your device. So that's wonderful, and oftentimes they're narrated by the authors with wonderful voices, or they will hire someone with that can do lots of different accents and voices, and it's just absolutely wonderful. So I would encourage you to read. I've got a video here that I created last year. I create one of these every year, the favorite books that I read in any given year. So I encourage you to read that. That's on my Our Earth channel. And I would love to share some of those with you at some other time. Feel free to contact me. So in here, I've got all my titles of the books that I've read over the year. All right. Travel. I know it's expensive. I know it's time consuming, but travel. It's part of that whole opening yourself to different cultures, to different viewpoints, backgrounds. It's a wonderful learning experience. It helps you in your research also. If you can't travel, at least get outside. Everybody can get outside. Getting outside helps you think thoughtfully about the world, helps you look at the natural phenomenon around you, and think deeply and get some peace away from, your devices, perhaps. And there's lots of other benefits for getting outside, health reasons as well. And also go beyond your disciplinary comfort zone. That's another way of expanding your horizons. So at a conference, for example, go to a track that's not in your own wheelhouse, the things that you're familiar with. I do this at every conference that I attend, and I meet new people. I learn about their methods. I learn about what they're interested in, and so on. So I encourage you to do the same. Where is this? This is probably the most famous intersection in the world, Abbey Road. Okay, so that's on one of my travels, on one of my work travels. Build your network with care. Why do I say with care? More about that in a moment. But build your network. Find someone in academia, government, local to international agencies, nonprofits, academia. Your teachers and professors can be great resources for you as you move forward in your career. Mentors, collaborators. But choose wisely. Choose people that are positive, that are not going to bring you down, that are fun to be around, that are interesting, that help you grow and move forward. Okay, so build your network. That's important as we all are sharing and want to collaborate as we build this better world. And finally, seek to be at the intersection of these circles, these ikigai, Japanese diagram. I love this. Seek to be at the center of these Venn diagrams, I guess you could call them. What you love to do, okay? What you're good at, what you can be paid for, and what the world needs. Am I always at the center of all those things every day at work? No, but I strive to get there. I love what I'm doing as a geoscientist, geographer, educator, geographic information systems professional. I feel like I'm contributing to what the world needs in terms of spatial literacy in education and beyond. I feel like I can provide for my family. I can be paid for that work. And I also feel that with the experience and working in tandem with good people like yourselves that are watching this, that I've developed some skills. So I've got some background. So I'm good at what I'm doing. I'm actively seeking mentors, collaborators, because I feel like I'm a lifelong learner, and I'm still just getting started with this. So there's a lot that I need to learn still. But seek this in your work. Try to, when you realize how much time you're going to spend in your research and in your job, it's a lot of hours. It is a lot of hours. Don't choose something where you're going to be watching the clock saying, is it quitting time? Now, we all have our days where it's difficult and challenging, but seek to be at the center of this and seek something that, if it's an hour past quitting time and you're on a roll and you're working with collaborators, or you're all by yourself and you're getting a lot done and you're focused, hey, it doesn't matter that it's an hour past the time you were supposed to get off work. See what I mean? So seek to be at the intersection of those circles. Find something that you're really passionate about in life and keep moving forward with it, and it won't seem so much like work. In sum, research is interesting, it matters, and you can do it. You can do it. I welcome your questions and comments. Joseph Kursky here at your service. Again, let's keep thinking creatively about research and why it matters. And thanks for being with me today. I wish you all the best in your research study and beyond.